Hey guys, Miss Fearing here. Welcome to Unit 6 Notes 1. Today we're going to go ahead and look at some scientific notation. You probably have seen some of this in your science classes already or last year in your 8th grade course, but we're going to go ahead and we are going to re-look at it today for you. So scientific notation is a thing that we use to write really big numbers or really small numbers in a condensed, shorter way. When you're looking at this, there's a couple rules that we need to remember. That our base 10 indicates how many places are missing in our thing. So when you look at this base 10, the times 10, will always be in your answer if you're writing in scientific notation. So that is always going to say a times 10. The other thing we really want to look at is our coefficient. This needs to be a number between 1 and 10. Okay, so we need to make sure that we are moving our decimal point so that it creates a number between 1 and 10. Our exponent then tells us how many numbers or how many times we move the decimal and then which direction. So let's go ahead and use those ideas and then write number 1 here in scientific notation. So I know that I need this to be a number between 1 and 10. So I'm going to move my decimal point so it's all the way over between the 1 and the 3. 1.329 is a number between 1 and 10. If I moved it between the 3 and the 2, it would be 13.29, which is not between 1 and 10 like we want. I know that my base is always a times 10. So now, here's the trick. I need to determine how I move my decimal point back to where it started from. So if we don't see one in here, it started right here at the end. So I moved it up here and I want to move it back. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, and to move it back to where it was, it's the positive direction, so it's a positive 9. So let's look at number 2 here. I know that I need this number to be a number between 1 and 10, so I'm going to make it a 6.8. So now I moved it here and I want to see how I can get it back to where it started. So I'm going to move it 1, 2, 3, 4, 5. So I know I have a times 10. And because I moved that the negative direction, my power needs to be a negative number. So right now I want you to go ahead and I want you to try number 3 and 4 on your own. Make sure that you're moving your decimal so that the number is between 1 and 10. And then your power is how you move it back to where it started from. Move that decimal point back to where it started from. So pause the video, try 3 and 4 on your own, and then come back and check your answers. So for number 3, I got 2.457. You might have had 2.456, but be careful. When we look at this, that number there is bigger than a 5, so we need to round up. And you may be asking, well, why, Miss Fearing, did we stop at those numbers? Why didn't we write the rest of them out? So I always do 3 digits after the decimal point. Once you have those 3 digits down, then you don't have to write the rest of it. Remember, we want to write these in condensed ways, and if I was to write all those numbers out, it wouldn't really change any way that it was written. It wouldn't make it any smaller for me. So we always do 3 digits after the decimal point. Number 4, then, I got 8.9 times 10 to the negative 11. Remember, we're looking at how we moved it back. So I moved it here, and to get it back to where it was, I went the negative direction. So now we're going to switch it up a little bit. I'm giving you a number in scientific notation, and I want you to write it in standard notation. So I want you to write it without the times 10. So what we do for this is we go ahead and we look at that power. That power tells us how much we move the decimal point and which direction we move it in. So that one's going to tell me I'm moving it 5 in the positive direction because it's positive. So here's what I'm starting with, 3.267. I need to move the decimal point 5 to the positive direction. So I'm going to go 1, 2, 3, 4, 5. It's going to be right there. So I need a placeholder here. So the placeholder that we use that won't change the number then is our zeros. So we want to add zeros to those places that are missing. Our times 10 disappears then, and we are in standard notation. So number 6, then we're going to look again at that power. That power is a negative 3 this time. So I'm starting with 4.567, and I need to move it 3 in the negative direction. So I'm going to go 1, 2, 3. It's going to go here. So I'm going to have point, put my placeholders in, 0, 0, 4, 5, 6, 7. Okay, go ahead again. I want you to try 7 and 8 on your own. Pause the video and then come back and check your answers. So here's the answers I got for 7 and 8. If you got something different, please come talk to me before moving forward with the rest of the notes. So now we're going to talk about operations with scientific notation. These properties or these operations, the rules that we have going on, are the same that we've kind of talked about when we were talking about our exponent properties. So keep those in mind when you're working through scientific notation. They're still exponents, so they still have the same properties. So when we're adding or subtracting operations with scientific notation, our exponents need to be the same. It's really important that this happens. If they're not the same, then we have to convert them back into standard form before we can add or subtract. If they are the same, then we just add or subtract the coefficients and the power stays the same. So our base 10 to the power, that would stay the same. Think of it like adding or subtracting like terms. They don't change. Our x squareds plus our x squareds don't become x to the fourths. They don't change. They stay x squareds. So it's going to stay the same way with scientific notation. When we're multiplying, that's when we multiply the coefficients and then we add the exponents of the base 10. So we're going to add the exponents. Remember, that's the same thing we did. When we multiply, you add the exponents. And then division, we're going to divide the coefficients and then subtract the exponents. Okay? Make sure that if you get a final answer, in order to be in scientific notation, we need to have a number or coefficient be between 1 and 10. So make sure that if you get an answer that doesn't have a coefficient between 1 and 10, you're not technically in standard form, so make it between 1 and 10 and change your power. So let's go ahead and look at our next example, number 9 here. It tells me to perform the following operations. If possible, leave your answers in scientific notation. So this is really important here. We want our answers to be in scientific notation. So for number 9 here, I'm adding these things. So in order to add, our exponents need to be the same. So in this situation, they both have a power of 10. So that's good. We are good to just go ahead and add the coefficients now. So we are going to add the 0.37 and the 4.57. And when I do that, I get 4.94. And remember, when we're adding, the powers are just staying the same. For number 10 then, this tells me I'm multiplying. When there's nothing in between there, that means you're multiplying those things together. So to multiply, remember, it says we multiply the coefficients. So we're going to multiply 2.37 times 3.47. And I get 8.223. And when you multiply, remember we add the powers. So I'm going to add the 4 and the 3. So I have times 10 to the 7 then. Looking at example number 11 here, this is a division problem because of the division bar there. That tells me to divide. So when we divide, we're going to divide the coefficients. So we're going to go ahead and we're going to divide 9.6 divided by 1.6. When I do that, I get 6. And then when you divide, we subtract those powers. So we're going to subtract 7 and 4. So 7 minus 4 gives me times 10 to the third. Here's a little tricky one when we get to number 12. Number 12 here tells us that we are subtracting. So in order to subtract, our powers need to be the same. Well, right now I have a 4 and a 6, so they are not the same. So in order to do this problem, we're going to move them both into standard form. Then we're going to subtract them, and then we're going to move them back into scientific notation. So to move it into standard form, I need to move this one, the first problem, 4 in the positive direction. So move this decimal point 4 in the positive direction. 1, 2, 3, 4. I end up with 4, 8, 2, 0, 0. Minus, I need to move this decimal, it's 6 in the positive direction. So I'm going 1, 2, 3, 4, 5, 6. So I get 3, 4, 5, 0, 0, 0, 0. Remember, those placeholders are zeros. So from here, I can go ahead and I can actually subtract these two things, and I end up with a negative 3,401,800. But it's asking us to leave our answers in scientific notation. So I now need to move it back into scientific notation. So I need this number to be between 1 and 10. So I'm going to make it negative 3.402, because remember we want to round up there. And to move it back to where it was, went 1, 2, 3, 4, 5, 6 in the positive direction. So looking at our last examples here, I want you to go ahead and try 13, 14, and 15 on your own. And then we'll come back, we'll check our work, and then we'll do 16 together. So pause the video, try 13, 14, and 15 on your own, and then come back and check your answers. So here are the answers I got for 13, 14, and 15. When it came to 13 and 15, remember we need our answers in scientific notation, so we need the number, the coefficient, to be a number between 1 and 10. So 15 was not a number between 1 and 10, so I had to move the decimal over, and then I had to add 1 or subtract 1 depending on the direction I had to move the decimal back to where it was. So if you got anything different on these, please come talk to me. When we are looking at these, also keep in mind, it's okay to have negative powers for these. Before, we couldn't have a negative power. We had to flip it to make it a positive. But right now, when we're dealing with scientific notation, it's okay to have negative powers. That just tells us the direction it's moving. So let's go ahead and look at number 16 right here. We have multiple operations going on in here. So what we want to do is we always want to do the side of the fraction that has multiple things happening. So we're going to simplify the denominator first. So we're going to multiply those two numbers. So the top is still going to stay 6.48 times 10 to the 5th. And when we multiply the coefficients. So we're doing 2.4 times 1.8. I got 4.32. And then we add those powers. So 4 plus a negative 2 gives me a 2. Now I can divide. So I'm doing 6.48 divided by 4.32. And I get 1.5. And when you divide, you subtract the powers. So 5 minus 2 gives me 3. So next stop for you is the practice. If you have any questions, come chat with me. I'm here for help.